you for showing up. Aaron asked me to come to the conference so that we could spend our time productively at the end of the conference doing an improv comedy show, the Speechless thing, which is on at 4:30?
Yeah, 4:30.
Somewhere.
In the keynote room.
In the keynote room. 4:30 in the keynote room, and I said, that sounds fantastic. Unfortunately, I don't do comedy for a living, I actually program for a living. So I said, okay, give me a real reason to come to the conference that I can try to justify in my expense report, like giving a presentation. And he said, great, I've seen some of the presentations you've done around process and methodology, and they're really funny. Why don't you do a satire talk? And I said, that's also really good. Why don't you give me a different reason that I can actually use on my expense report? Which is why I gave a performance talk yesterday.
I really tried.
But this afternoon, I thought I would talk a little bit about process, because that's something that's desperately important to me in my role as a consultant and a process methodology. In particular, I've spoken about the broader topic of process before, and in particular about software development patterns before, but today I wanted to talk about something very trendy that most of my clients will pay a lot of money for and very high billing rates. Best practices. In particular, I want to talk about best practices for software practitioners who practice software development practices. Practically. My name, of course, is Chet Haase. I'm a process methodologist. You may know me from such other talks as Crystal Methodology, Future of Effective Software Process Methodology Effectiveness, and Patterns, Schmatterns. And today we'll be focusing specifically on various software patterns that I think are important, not just in helping develop quality software, but more importantly in building client relationships that provide very high salaries. Now, it's a known anonymous quote, that practice makes perfect, which I think is a fantastic quote, except that it's not mine. So I tweaked it a little bit. And in reality, practices make perfection. And I like this quote a lot, mostly for the fact that I came up with it. But I think it's pretty clear from where, in particular, where we use bold fonts, how important this is to this talk on software best practices. What's more important, though, is that we actually see it spelled out in the data. It's easy to say words, especially for me, when I have a microphone. But it's harder to actually understand the numbers and the qualitative and quantitative data behind it. So I've developed some graphs for this. And you can see, this is some data that we accumulated onto the chart throughout a year. So this takes us all the way from January through December. There's some implicit months in the middle, and you'll just have to take my word for it. They're actually in there. And you can see that the amount of perfection you're achieving is steadily going up during the year, which is fantastic, even hitting 100% just due to the total amount of practicing that was happening during the year. Now, of course, this is anecdotal. This is just one particular survey of one particular customer that I was billing high rates for at the time. But I think it's pretty stunning data. I think you'll agree with me. There's another quote that I think takes it even further, though. And that's that practicing practical software development practices makes more perfect software development practices. Now, the element here is that it's important not just to practice to get better at something. It's important to practice software practices. Now, here's some more charts. You can see across the line throughout the entire year, again, some implicit months in here, but going from January all through December, every single month in which that customer practiced software practices, they were hitting 100% of practicing software practices effectiveness. I think that's stunning. Unfortunately, they had the team outing in March and they failed. So first of all, I want to cover some traditional best practices. These are practices that you are probably already using. I know my customers are, and I want to talk not just about that they exist or that people are using them, but why they're effective and why they're using them, and maybe some of the things about these practices that you may not realize at this point. First of all, there's code comments. I think everybody agrees that comments are really important. So here we have a sample method. Okay, this is a simple getter. We're going to get a calculation result that's going to return a result that was calculated previously. So that's good. It's pretty self-explanatory, right? Who notices the problem here? Anybody see this? Besides, the font is a little bit small. Okay, so that's problem number one. It's a little bit small, doesn't take up enough of the slide. Anybody else? Not enough lines. That's a good one. It doesn't relate to the topic. Yes?
Where does calc result come from?
Where does calc result come from is completely irrelevant to the context. Sorry? It's undeclared. Oh, calc result again. Still irrelevant. Too much code. Oh, that is so close to the topic. Yes, sir?
There's no comments.
Excellent. Oh, fantastic. Well done. I cannot believe that it took us so long to get to it. Unbelievable. Let's see what we can do to make this a little bit higher quality than it is right now. First of all, we obviously need to write in some comments about the implementation. The problem is, with a lot of the software that we develop, sure, we wrote the code, we did a damn fine job of calculating that result, more importantly, returning it here. I mean, I can almost guarantee with about 49% accuracy that there's no bug in that line of code, right? I think it's a fantastic line of code. But what happens when I leave, right? I'm a consultant, I go on to a different contract because they're going to pay me more. And they're going to hire somebody that didn't write this code, and they're going to look at it going, I don't know what calc result is. More importantly, I don't know what this method is doing. Why are we returning calc result? So we need some implementation details in there so that the code can be maintained, right? But then you write the code once, but of course, maybe there is a bug in there. Maybe I was wrong. It wasn't 49%, it was actually only 10%. There was a bug, and so we had to modify it. We actually had an off by one error in there. But people in the future won't know that because they're new to the project. They don't know what happened, so it's good to write in some information about that. And of course, it turns out that it wasn't a one off by one error, it was an off by two error. And then later, we actually realized, no, it wasn't off by one error, so we had to back that out, and we had to fix the then off by -1 error. So now we've got all the modification and implementation details that a future maintainer would need to actually keep this code going and be just as robust and effective as it almost was the first time. But you still need a little bit more information here, because this is all implementation, right? This is not going to be propagated to the people that are actually using this API. So what are they going to do? They don't know what's going on. All they see is a method called getCalculationResult. That's not going to mean anything to them. What's a calculation result? What does get mean? Right? So let's give them all that information. So first of all, it's important, and I would say this particularly for the consultants in the audience, to always put your name in the code. They're not going to hire you back if they didn't know that you worked on it. Right? So go ahead and put an author attribution in there, terribly critical. You're going to need to also put some references in here. It's important if they want to know what a calculation result is. Well, what can they refer to get more information about that? What do they need to know about calculations? What do they need to know about results? What do they need to know about estimates, or getters, or software process and development in general? Everything you can think of that they might want to understand should go in a section on references, obviously. It's also important to say what can go wrong here, right? Something could go horribly wrong, calculation result could be null, and we're dereferencing into it for some reason that I don't quite understand in this line of code. Anything can happen there. You need to document all of those particular occurrences. You also need to say what's going to actually be returned, right? What are the possible return values? What's the meaning of these return values? Why would people possibly want this thing? You want some error situations in here. You want to make sure that if they get a NaN back, they have to understand what that thing is. You probably need to add that to the references section, of course, as well. And then finally, we need some header comments, and this is really sort of the main section you want to never forget, is to explain what is meant by getCalculationResult in the amount of detail that's appropriate for the method. Now, of course, I'm using very little description here because there's only a single line of code. If there were 2 or 3 lines of code in the method, we could go on for pages and pages. And then finally, you want to say what the method name is, because the problem is, once you get this many comments in there, you sort of lose what the method is. Moving on, let's talk about some naming conventions. So I think it's clear that we need some conventions in naming. This is for method names and fields and classes. We need to understand clearly when we're reading the code, when we're looking at the API, what these things mean and what they're being used for. So we need things to be clear. We also need them to be maintainable because, again, of course, as consultants, we're going to go to the highest bidder and they're going to hire new grads instead. And obviousness, what I would call obviousness. When I look at the API, when I look at the code, does it simply read well? So I have an example. I thought it would be better, instead of talking on and on and on and showing charts and data, to actually show some sample code that I wrote that I think demonstrates some of these principles. So in this code, there's several instances of the clarity and the obviousness that I'm going for here. One is that it's important for them to know who wrote the code so that they can hire me back in the future, probably for a higher rate. This is the first method that I wrote on that day, so it's important to write that one down. X is a really important variable, and I wanted people to understand that. So that's why you use an exclamation in the point. We learned our languages with particular syntax and punctuation. I think that should carry over in the code. Why? Not quite as important. I frankly couldn't even figure out what it was being used for in the code. So I put a question mark by that. Now, it's not clear when we're calculating this integer what the answer is going to be, especially since we're not even sure what y is for. So once you divide through by it, I don't even know what the result is going to be. It's important to note that thing here. It's especially important to note with all caps whenever possible, so that you're actually shouting the information that you have in your brain to the reader of the code. And then finally, it's important to call other methods that are similarly named. Everyone knows, oh, this must be the Chet module. This is another routine that Chet wrote, and it must be the 7th one that he wrote that day. It actually wasn't. It was written in the 7th month that I was employed on the contract, but the numbers still work, right? It's consistent, right? So then we're going to pass in the who knows variable and the right. Okay, so this is a Boolean value that we're passing in. We're very certain about that knowledge. Yes, sir?
Rules is not always in caps. Is it normal or is it part of the naming convention?
The not all, the who what?
It's not in caps on the second line.
Yeah, who?
On the third line, it's not in caps.
On the, oh, you know, this is part of the special syntax that I was using here. So people that are actually programming in Java, some of the languages out there that have sort of cottoned on very recently, may think, you know, I'm not even sure that this will compile. Which, I mean, first of all, to be frank, that's a little rude because this is my presentation. I think you should reserve your judgment and just sort of keep your nitpicky engineer opinions to yourself. But in fact, you're right. It actually won't compile in any language that I know of, which is why we needed to develop a new language for the program, which resulted in not only the ability to actually compile this in the language that I thought most obvious and useful to me, but it also, more importantly, meant that we could build a client for huge amounts of money. This was probably the most popular and most profitable contract of my company for the span of a 5-10 year period, simply because we had to provide a new language that was developed in a research department, compilers, interpreters, packaging situations. It was a huge windfall for our company. The client, unfortunately, went out of business. So the next pattern I want to talk about is simplicity. Again, this calls back to the codes, the idea on the previous slide, where you want obviousness. You want the clients, you want the users, you want the developers to actually understand everything. The code should actually, in my opinion, read more like a story. You don't want them to have to parse syntax and then translate that into their brain into the types of things that we as people understand. Again, I thought it'd be easier to explain with an example. This again was a custom language that we wrote for the same client right before they went out of business, unfortunately. So this project wasn't finished because then we had to figure out someone else to go build. So in here, obviously, I mean, this is so clear to me, right? We all grew up reading stories, having stories read to us, and I think the code should be just that beautiful. Bob and Mary Ann actually did go to the store. And then the go-to, you'll see this cleverly takes you right onto the next line. Now, who's seen go-to statements that take you somewhere else in the code? I think those are completely irrelevant, right? Like, why jump me somewhere else? Why not just take me to the next line? It's right there. It's like, why get in the car and drive to the door, the neighbor's house next door? Just walk across. It's right there. So we're going to go to the store, and then we're going to ask the question. This is a Boolean operation. Who shot Bob? Right? And we use this Because all we really want to do here is ask the question, because it's an interesting question to ask. The answer actually doesn't matter, but I love the syntax of the 0:0. It kind of looks like it's a smiley with a really big forehead and a huge open mouth. I just think it's pretty in the code. And the culprit, of course, I mean, obviously, it was Marianne, his wife. We all knew it, right? But what we really want to know is why Marianne. And then this takes us to another subroutine that will explain more of the story. And we can just read the code over and over and all through the day. And it's just entertaining from one end to the other. We don't actually know what it does yet, but we want to find out, right? I think code should be that fascinating to us. So another pattern, of course, is portability. What you really want is for the code that you write to be able to work, at least in some semblance, in different environments. If I write this Java code, wouldn't it be nice if I could just take this over to this other environment in which I'm using C++? Well, I have to change some of that syntax over there, that's a pain. And then what if I actually wanted to get to work on Fortran? Well, that's a completely different beast, right? And so we're looking for these situations in which we can take our code modules and make them as portable as possible using libraries and frameworks and higher level languages, whatever it is that takes so that we can carry our code with us onto the next client, bill them for the same amount of work, but just reuse the stuff that we've already done. So there's all sorts of reasons, there's diverse platforms, there's computing platforms that get more powerful over time, but then they change architectures that we need to build on, and so we need code that really carries over. Once again, I wrote an example that I thought would help explain this. So this is code that we wrote for another client. We created this new language that I call Basic Script. And what we're able to do with Basic Script is write in one of the beautiful languages that I grew up with, one of my favorite languages, which is just straightforward basic. I think this has to be the most powerful and beautiful piece of code I've ever seen. What you end up with is a loop that just prints fart over and over. It's simple, it's effective, it executes in just 3 lines of code, and one of them is irrelevant, but seems to be required by BASIC. Now the important element here, of course, is that it be portable. Now, you may not have BASIC running on your machine, but you do when you buy my BASIC interpreter, right? So what we do is we wrote this language, this interpreter, this compiler, this runtime that we then package up with the code that we wrote. So we had about 1,000 lines of code in the customer project, and then we had a 64 gigabyte runtime that we packaged that made it able to run this simple and same exact code on any architecture on which that runtime worked. And that was essentially the IBM 360, and there were some older mainframes. We had a hard time porting it after the 386, so it doesn't work on current or even past PC architectures. And the Mac OS export is still in progress, but I think the idea behind it is really beautiful. I hope you agree. Another important concept, of course, is continuous integration. You need to build, you need to test, and you need to repeat over and over and over again. As you work on the code, keep making sure that it continues working, right? As you add functionality, let's make sure that it's the functionality that you actually want, and you don't have to go back later and fix it. But the real advantage of continuous integration is that it requires more storage, more servers, and a huge amount of bandwidth for this continuous upload and download and test and stuff flying around on the network all the time. It's unbelievable the amount of hardware and infrastructure that you have to invest in to make this work. And of course, the larger the IT budget is, the larger the consulting contracts are. So in the end, it works out beautifully for the consulting companies. Testing, of course, huge area of development in the last few years. I think it's clear to everybody that the more tests you have, the more confidence you have in the product and the quality of the product. And then when you write more tests, you have more confidence, and then when you write more, and it just goes on and on and on. It's the gift that keeps on giving. Right? The more you invest in tests, the more you are investing in the idea of quality in your product. Once again, I thought it would be helpful to take a look at some charts and data for this stuff. I think it's pretty clear from this data that the number of tests that we invest in increases directly, one-to-one correspondence with the amount of confidence we have. I can't remember what the units are here, but but they're big. They're big units. Right? So let me go into a little bit more detail on what I mean by testing. So let's say you have a module, there's some methods in that. We need to make sure that this one particular method actually works correctly. So we're going to create a test around it. We're going to call that method and make sure that it returns appropriately. It does what we expected. Now, if that works once, we need to make sure that it works in a variety of ways. I want to call it from the end of my code. I want to call it from the beginning of my code. Maybe I want a different module to call into it. I'm just going to create all these tests and tests and tests and basically just surround it. You can think of it as like Custer and the Native Americans, right? Just clobber it from all directions and make sure that it's just completely wiped out in a way that's embarrassing forever for that method. He'll never fail because he's been thoroughly and completely obliterated by the test. Okay, so once we have all these tests testing this individual method, of course, we're going to need to loop on that a lot. And just call it over and over and make sure that there's no non-deterministic failures in how you're calling the method over and over. And then once we have that, it starts to get a little bit complicated. So what we really need is a testing framework. So we're going to write a new framework that knows how to run loops, that know how to run almost an infinite number of tests on each single method in there. And then of course you're going to need another framework for other types of methods or other types of situations. And then once you've got that, you probably need some more in there. And then you need some more method calls in there. And then eventually you get to a certain level of complexity, and you've got all these frameworks sitting out there individually that you're running into and maintaining separately. So of course you need a framework for your framework. And this, I mean, you have to keep in the back of your mind how much you're billing for this amount of work all the time, right? I think that's an important element for everybody to understand. So of course, once you have that framework, you're going to need other frameworks. And then once you have those frameworks, of course you need a framework to run them. Just a huge amount of not just quality, but profit is involved here. Yes, sir?
To ensure you don't have bugs in all this, because it's starting to get somewhat complex, do you have a test framework?
Oh, absolutely. I'm not talking about the framework testing framework that's sitting off to the side here. Yeah, we've got a whole separate group that's actually working on testing the frameworks themselves. Absolutely. That's a great question, sir. If you want to come up afterwards, if you have a resume. All right, so I also want to talk about process. This is an important best practice in general. As I said, I am a process methodologist, and I'm a firm believer in process. And here's why. Because it's a dependable routine for developing, testing, packaging, and shipping the product. But more importantly, from my perspective, it just makes a lot of money for the consultants. So I think everybody should invest as much in process as possible, hopefully by hiring me. Okay, so that's all the standard best practices that I wanted to talk about today. And before I talk about some of the new processes and ideas that we use internally in my company and that I build clients for, I wanted to talk a little bit about software quality in general. So let's talk about a couple of laws. I developed these because I like to do that because then I can actually charge more for them. So the first law of software quality is essentially the more code that's written, the more bugs there are. And that's a quote by me, and you can quote me by it as long as you attribute it to me. It's a quote that I said. Just now, actually, I just said it. But I think this is kind of obvious, but it's really good to dwell on it as long as possible. In fact, there's another way to express this that I think is really important. This is another way of expressing that I came up with, which is the number of errors that's directly correlated to the amount of more code. It's a little bit awkward, I know, but it's the amount of more code squared. It's an exponential relationship between these things. And the best thing about this is that we end up with this other way of expressing that I found to be true over and over and over again. It also helps if you express it mathematically like that, because all of the engineers in the room can then immediately understand that and say, gee, that sounds familiar, because you heard it here. The second law of quality, of software quality, is of course that the more bugs there are, the less quality the software has. Again, I said that just now. I don't know if you knew it was me, but I said that. So let's take a look at some different ways to slice this data and really understand what we're getting at here. And it's all about, again, bugs and quality, and there was an E in there somewhere. And so, first of all, let's pretend that you have some software that you wrote. There's tons of lines of code in here. We have some headers. We have a nice amount of documentation. I would probably write a lot more, but so there's a fair amount of stuff going on in there, a fair amount of logic. Now let's compare that to this other file and just look at the quality results of both. So here's another file of code that we wrote for the customer. So it's pretty clean, right? Because it's completely empty. Now, the interesting part is not the content in there. Like, nobody can read that code. They're not interested in reading and seeing the details of the code or exactly how empty that other file is. Instead, let's look at the data associated with it. So we can slice this in a couple of different ways. We can say, well, how many bugs is in this code? And you know what? There's probably more than 0 in this code. Probably more. And does anybody have a guess for the one on the right?
Absolutely no.
0, exactly. If I had a giveaway, I would give it to you. And then I would charge you for it. 0 bugs, all right? That's the takeaway from this presentation. Empty file, 0 bugs, all right? But there's another way to look at this, and that's in terms of quality, not just the number of bugs, but a qualitative measure of how good is this thing. And I think we can say with some certainty that the one that probably has more than 0 bugs is what I would say is qualitatively worse. And the one on the right is the best. And I think we can highlight this a little bit more with some graphics, all right? So if you're charging your customer, which is the one that you want them to use and remember you for? The one with the highest quality, all right? It's important to look at different ways of slicing this data, though. So here's one where the amount of code in unspecified units monotonically increases with the number of bugs in the code. All right? Maybe you thought that was obvious before, but I think once you look at the chart, you're like, I never would have pictured it that way. I should hire this guy. Now, another way to look at it, if we flip the data around, it looks like this. I also find it useful to use different types of charts because it helps me understand different mental models of how the data is actually constructed. So we took all of that data and we threw it into a 3D chart. And you can see here, even though it's facing in a different direction and it's got this perspective projection on it, and it's coming out toward you, a little foreshortening in back there with the smaller object, number of lines of code increases, number of bugs goes up, right? Huge. Looking at it from a different perspective and a completely different color, I'd like to point out, same effect, same exact effect. And then one final time, if we go down to the bottom of it and we look up, same effect. Unbelievable. Over and over, the data just drills it in and in and in until it hurts like the dentist. Okay, so how do we get to better quality software? There's a lot of different ways to do that, and those are the practices that I really wanted to get to today. So what you really want to do is get to higher quality. Well, you do that by creating fewer bugs, right? Now, how do you create fewer bugs? You write fewer bugs. Let me go over that again. We want to get higher quality by creating fewer bugs, which means we're going to write fewer bugs. I think that's huge. That's takeaway number 2 from this presentation, in addition to my business card. And the way that we get quality and fewer bugs is by writing less code. So let's talk about some best practices for doing that. So first of all, there's hiring practices. It's clear from the data that the number of programmers you have working in your organization directly correlates to the amount of code that is being produced by your corporation. Now, I've seen this again and again. I've worked for clients all over the world, and this is true everywhere. This is a mass of data that we've gotten from all of our clients. We put it together in this one chart, and we looked at it. It was stunning. The first time we saw it, we said, look at that. The number of programmers increases the amount of lines of code produced by those organizations. Unbelievable. And here's the one that's not as obvious. The number of people that don't program is directly correlated to the quality of the software product. And I think this is clear for several reasons. If you hire fewer programmers, there's less people writing code, there's less people writing bugs, there's higher quality of the product. So what you really want to do is you want to hire managers, program managers, marketing departments, overhead administrative details all over the place, facilities. You got all kinds of job functions in your organization. People that don't need to be writing bugs for your products, right? Hire them now, and most importantly, hire more consultants. So there's a lot of different ways to achieve this. One is through hiring. Another one is through resting. So it's clear that the amount of time, not just the amount of programmers in your organization, but the amount of time they're actually spending programming also directly correlates to the amount of code that they're producing, and inversely correlates to the quality of the product. Now there are different ways of resting. I, for one, suggest spending more time in the restroom. That's what it's called. In many of my organizations, it's impossible to get an office of your own. It's almost impossible to book a conference room anywhere, but there's always little rooms with doors available. You can just go in there any time of the day and spend some time with yourself. There's devices, there's fantastic games and productivity apps that you can play with. As long as you remember to come out for lunch, because it's important to have a little bit of work-life balance, I think. There's different productivities that I think productivity tools come in handy. Monitors. I think that all IT workers should have huge multi-monitor setups. That way you can actually watch the game on one of your huge monitors here, while on your main monitor you're watching the other game. I think that you should have the fastest machine available, because if you are watching a movie, you don't want that to interfere with the quality of the other movie that you're watching, right? You want that machine to be able to do multiple things all at the same time, and not take you down in the productivity of the non-programming tasks that you're trying to accomplish. I think keyboards need to be really strong, sturdy, and clicky. They need to be that clicky-clacky thing. Like there are some keyboards that are very low profile that you can't even hardly hear, right? But what I suggest is that you get one of the keyboards that really makes tons of noise, because then your coworkers in your office will ask you to type less. And then finally, you should get some headphones on, because there's usually a lot of noise happening around you, and that really interferes with the soundtracks of the games and the movies that you're trying to watch. Okay, so let's talk about coding style. This is kind of a huge best practice area in general. There's entire books around it. There's entire consultants' careers that are built around coding style. And I agree that it's really important. I agree that it's important to have consistency, mainly so that you can remember what your style is next time you go to actually write the code. But there's also the requirement for readability, right? We already talked about comments, but there's also issues around how long should the lines be, how much blank lines should you have. I think it's really good to make your code as readable as possible. We went over that, but this is about creating white space and a comfortable environment in which the code can live, to make it pleasing to read that and get all the information you need to out of it. So the things that I go for here are comments, as we talked about before, as many as possible. Line length, a lot of people suggest 100 on modern monitors. You can really go pretty wide and see it pretty easily. The standard length is usually 80. I usually aim for about 20 or maybe 10. Less than that if I can get away with it, with very small variable names. And that means the line wrap that you use monotonically increases with the number of lines of code in the file. And I find that to be really helpful, because then sometimes I build clients based on the number of lines of code I produce. Blank lines, same thing. Hit a lot of carriage returns. They're free. So let's look at some data. It's pretty clear that the number of lines of code directly correlates to quality. However, in this case, if you'll notice, the previous graphs were using the color blue, which was sort of a pleasing, comfortable color, and the line was going up. And usually you want the line to go up here, red, down, right? Quality goes down as the number of lines of code go up. Okay, that's how I made the graph, right there. Okay, so what about comments? Well, the number of lines of comments that you add goes up monotonically with the amount of quality. And the reason is because the more comments you have, the less percentage of actual logic you have in your file. And the less logic, the less bugs, the higher the quality, right? Line length, now this is sort of an interesting curved because it's not straight. If you notice that, it's a curve. That's why it's a curve and it's not straight. See those straight lines, not straight lines. That's why I thought it was interesting. So number of lines of code in your file increases with the quality as long as they're the right kinds of lines of code. In particular, if you write really short lines of code, did I get the data? I don't, I'm going to move on to the next graph. This But the fascinating one in the next one is that we're going to fade in something else. We're going to talk about blank lines. The number of blank lines of code increases the quality because you're saying my files are more and more long, and yet the quality goes up because all of those lines of code didn't have any logic on them whatsoever. Again, third takeaway from the presentation, carriage returns are free. And then finally, I want to look at what happens if you look at these and other factors and you put them all in the same data chart and you say, well, where are the trends? What can we do about this information? And you can easily put this into a chart. I used a different charting application because it got pretty complicated in there. And if you look at this, you've got quality on the bottom going from 0 to 100%, and the higher up you go in quality, the higher you go up in the units. This is units on the left. And those correlate directly with quality with various metrics that we have. And I think, I don't even need to explain this. I think it's obvious. And I just want to leave you with one word, and that's practice. And then I want to leave you with 3 more. And one of them's not even spelled correctly. But you know what? I bet we could write some tests for that. Thank you. We apparently have 22 and a half minutes to waste still. If anybody would like to ask questions, yes, sir.
So, pair programming is popular in a lot of places, but I'd like to know how that figures into your pairing and code quality and code production.
So pair programming, the question was, how does this figure into best patterns? So I've spoken about some of that stuff in previous talks, and I've certainly built clients for it. There's a couple of different aspects of pair programming that I find interesting. One is that I actually prefer apples. The other is that the French are actually using a model that I think works very well for them called O-pair programming. I think that traditional pair programming suffers from the problem where both of those programmers want to write code all the time. Everybody wants to be the driver, right? Nobody wants to actually be the backseat driver, right? Because nobody likes the backseat driver, right? They know what they're doing, just back off, I'll write the code, right? So that doesn't work well over time. What does work is to have somebody help out in an O-pair situation where they're straightening up your desk and taking care of the kids while you're able to focus on the code, right? And that's a huge productivity boost. So, that. Yes.
Blank lines are free, but there's still sometimes you have to keep carriage return. What do you think about copying and pasting a lot of blank lines? And in general, what do you think about copying and pasting? Do you copy and paste quality as well as you?
That's excellent. I would almost quote me on that. Can you copy and paste quality? Wow. Again, if you have a resume with you. So you can copy and paste carriage returns. However, it's never clear whether you're going to copy the thing that you thought you were because maybe your cursor was somewhere else. Maybe you got a bit of logic and code that you copied instead, and then you end up with lines that aren't blank. And if they're copied out of context or pasted out of context, then they may not even compile. So what you really want to do is have a framework for copying and pasting, which is what we wrote for one of our clients and then build the rest of our clients for.
Do you have a text framework for the copy and paste?
I'm sorry, did you have your hand raised? Yes, you?
Do you have a test framework for the copy and paste framework?
The question was, do we have a test framework for the copy and paste framework? Of course. Test frameworks for everything. Yep, that's my motto. That's actually another, you can quote me on that. Yes, sir.
Does dress code affect quality?
Dress code does affect quality. I prefer my dresses to be silk usually. I think it feels really nice on the skin. Yes.
How many support libraries do you need for all of those test frameworks and, development systems for those languages you wrote for your clients?
There is only ever one support library. Thank you for the gratuitous applause break. Yes.
How about alcohol consumption? Does that adversely or positively affect?
How about alcohol consumption? That's a great question. I usually find it good if everybody drinks heavily before they come into work, because then by the time they've commuted into work, either they've been knocked out of the equation entirely, or the alcohol is really settled in and they can't get a damn thing done during the day. And once again, less code, less bugs. Fewer bugs. Yes?
You mentioned comments in the code, but you didn't mention anything about functional documentation for your end user.
Oh, documentation. That's the other part of my company. Yeah, absolutely. No, I was talking specifically about coding practices today and not the documentation practices. That's an entirely different presentation that Aaron would have to pay me a lot more money for. Next time. Not nearly enough.
You mean you got paid for this presentation?
My people are still in negotiation with Aaron's people on that exact topic. How does code generation? So how does code generation fit in? So we have old code and then we have new code. And those are the generations. So I'm sure you have a lot to think about. So maybe take your notes and go back and study it and then hire my company. Thank you very much.